last EDA vendor here. So that's going to be some repetition, but it's interesting to see how we all say the same message in a different way. So what I'm going to talk about on terms of unlocking AI advantage with Siemens EDA products, I've been in Siemens for the last 10 years, and right now for the last couple of years, I'm leading the AI initiative for Siemens EDA from a product perspective. So I have some insights on what we're doing. So feel free to interrupt me for any questions. So the challenges are always the same, right? The design volume is increasing. That's just 1 trillion already been done, already been said. Complexity is exploding. Cost schedule is skyrocketing. According to the latest reports, it's close to around 320 to 400 million in terms of designing the latest chips, right? So the stakes are quite high. So we can't make a mistake in terms of EDA software. The talent shortage, we've been talking about it. Everyone has talked about it. So just for US alone, for the next couple of years, it's going to be about 40,000 engineers talent shortage. So all these are definitely focused on design productivity. If you look at the chart over there, as we are moving from one across the process nodes from all the way to 2 nanometer, the amount of effort or amendments required across all different prototyping, verification, and software, the man hours required is actually increasing. So this is definitely, it's interesting because the time to market is actually shrinking, whereas the challenges or the amount of hours you need to get a chip out to make it work actually is going the other direction. So what we've been doing in EDA, it's been discussed, right? We've been investing in EDA as first form to make sure that we have automation. We've been figuring out new tools, new methodologies to bring in better automation, verification techniques. That was a great session from you. So definitely coming up with new verification. A lot more in terms of design reuse, like hierarchical design and so forth, that's been happening. And employee training and development is happening, and collaborating with a lot of research like IMEC and every other institutions in the world. So we view AI as another way for us to, at Siemens, to actually help you with your productivity challenge, right? That's how we are viewing AI. It's another I would say, a methodology or a tool that as an EDA companies that we got to adopt to make sure that we serve you better. So I'm going to talk a little bit about production grade AI in terms of the reason why I said production grade is exactly to the question that you asked last time, right? I think just before, why we are not on the cutting edge. Before I do that, we just did on the IBS study. It was interesting for a 5 nanometer tape-out. They had a traditional flow and they had flows with AI. When I say AI, it's also ML-based optimization as well. They definitely saw close to 50% on average productivity gain by using flows and methodology with AI and without AI. So one of the things that we are focusing on is to make sure that you have error-free design, it's repeatable, and comprehensive functionality testing. Right? Those are the key areas that we are looking at. But the most important thing that we find from customers, from experience, is any kind of innovation we do, they still always come back to accuracy and reliability, right? They say, yeah, you can come up with a good answer using AI, but make sure that it's accurate and reliable. Like that's always been I would say, the more compass in terms of how we are developing software in EDA. So I'm going to talk about some key components of what we call a production grade AI. So we acquired a company in Siemens EDA, part of a company called Semiconductor Design Automation. I don't know whether everyone knows about it. They came up with the first ML-based algorithm to do variation about design. What this means is if you want to get into high sigma verification, you want to run, for example, for a 6 sigma, you got to run 1 trillion samples to make sure you get a confidence level. They came up with a way of a very innovative way of using ML techniques to get to the same confidence level by using very few samples. So when that thing came, right, the first question when they went to the market was, people couldn't believe it, right? They came up with a great answer, but people couldn't believe it and they didn't trust it. So then they had to go back and see how we can get their trust, right? So that pretty much forms the foundation of how we are viewing in terms of our development. So in terms of production grade AI, the first key thing is verifiability, right? I need to be able to show, or we need to be able to show the proof of work in terms of how we came to a certain optimization, certain minima, certain answer. Usability is again, that was clearly covered by our person as well. It needs to be easy to use. You shouldn't be having a PhD person be able to run the flow. Generality is very, very important because I can't have a solution that only works for a certain low power scenario. It needs to work for across entire spectrum of the design space. Robustness is key. I shouldn't be giving an answer today, one answer, another answer tomorrow, or the same cycle, same design at a different time. And accuracy is the most foundation for us. So these are the 5 key principles we use in terms of developing software. We call it production grade AI. So it's interesting then when we bring a software product, these are all the different levels we go through, at least within Siemens. The first one, what we call it a partially reliable AI. I've been to many conferences where it's easy for anyone to come up with, for a given scope of problem, come up with an AI-based solution very fast, right? We call it partially, that's what we call partially reliable AI. But the problem is it gives you speed up, but sometimes you can get a wrong answer, right? So the first step takes probably an hour or days or probably weeks to come up with a solution. The level 2, what we call it a partially reliable AI, but with self-aware verification, which means that you got to have a software built in, you got to have the intelligence built in, where if you're coming up with an answer, you need to be able to actually self-verify to make sure that it covers it, it's accurate. The third one is adaptive. When we add an adaptive layer, which means that it needs to be able to be adaptable to all different design scenarios. It can't be working only for one certain configuration or this kind of design space. It needs to be across the board for whatever application you're looking at. And the last one, 4, is it needs to be reliable, accuracy, everything combined, what we call the production grade software. So any software that we provide, we need to go through these levels to make sure that the customers are kind of confident in the AI solution that we provide. And this takes time. This is where just to go from level 2 to level 4, that takes a lot of time, a lot of experience, a lot of collaboration with the customers to get a lot of design data and everything else. But that's the way that AI solutions actually come into the market. So I won't be talking about generative AI, but we all have co-pilots, different scenarios. But if anyone is interested, the very good conference is international conference for LLM aided design. Last year was a great conference. There's another one coming up. If you look at all the different LLM-based design flows, all the way from RTL generation, test bench, EDA chatbot, EDA copilot, high-level synthesis generation, security, design of documentation. There is so much research going on this particular way of using LLMs for chip design. This is a great conference. I would definitely ask everyone to go look at the proceedings if you can. But there's so much research going on that every month there's something new coming up. So we are still at the early stage in terms of how we can make this into a proper thing, but everyone is working on it. And generative design, AI design using LLM should be the future. Probably not yet right now from the EDA point of view. We're getting there with products slowly, but reliably, that's key. But definitely this is something that there's a lot of traction going on. So this is another way of looking at the life cycle. So of semiconductor, on the left side is from specification, implementation, spin off on the design side. Then you have test, package, then in service. So we have tools. I bet every other EDA vendor has the same tool to cover all these different scenarios, right? Different stages in terms of how we get the semiconductor to the market and into the field to be working. But the key thing that we are using AI is all the tools, all the AI capability that's coming into the tools is essentially to address the productivity gap. So we view from Siemens EDA, we bring AI in 3 different forms. The first one is called technology, where we have AI embedded in the tool. When I say AI, it's going to be ML or RL-based engines that's actually embedded in the tool. Processes means how you can make a very streamlined flow. So for example, take your fully entire place and order optimization flow, how we can make that much more efficient using AI. And the last one is a platform where it's essentially based on generative design. And how can we do that with better productivity gain, mainly to help your engineers much more like make one junior level engineer, like the other person said, to be a very senior engineer. And we have three categories of AI when we look at the AI. Analytical AI and predictive AI. Analytical AI is essentially solving a big data problem as a verification debug. That comes into that category. Predictive AI is where I use an AI or an AI ML-based algorithm or any kind of a model to actually predict an answer. In this way, I'm generating something. And generative AI is what everyone talked about it. That's where you come up with an LLM-based one where you get into more of a reasoning. Agentic is coming up, and then you pretty much have your virtual engineers, right? That's the ultimate goal, where you have one person just having like 5 virtual engineers in this team to get a tape out done. So 3 key categories: analytical, predictive, and generative. So I want to go through some of the key challenges and how we are solving it. The first one we're talking about is we're using AI to integrate systems across domains, right? In this case, cross-domain optimization. I think there's different examples previously. In this case, we are actually using an emulator and actually a sign-off power using Power Pro, where we are actually trying to. This is essentially used in the software development cycle, right? As you know, the software stack is developed using emulation as one of the key pieces. But every time an activity changes, they need to run the Power Pro or any kind of a power analysis engine, which takes a long time. So what we do is we try to do a pre-trained power model, and then we use that power model as an inference engine when the activity changes the next time. What this helps us, it actually helps us give definitely in terms of runtime advantage, but within the 5% margin of how we want to run everything from scratch, right? This is very important when you're doing an early phase in terms of prototyping or software development in your cycle, right? This is something that came up with. The second one is that 3D-IC platform. There was a question about, I think in the previous session, about what do you do in terms of how can you figure out the dependencies in a 3D-IC package. We launched a new product called Innovator 3D-IC. This is essentially a 3D-IC design space optimization platform, where you can go all the way from your package to your subblocks, right? You can do a lot of all the optimizations. It understands the entire stack so that you can actually plan from top down, right? And also get all the information that's here all the way from bottom up. And this uses a lot of AI and ML models. And so I'm on the transistor side. I'm on the analog background. So in terms of and the previous person that was placing route. So we have what we call another product called Solido Cell Optimizer. In this case, where we use MR and RL in a way that when you're designing a single cell, right, a transistor cell, like a standard cell, you need to come up with a perfect optimization cell across all different scenarios. And the best way to run it is through multiple scenarios in terms of test benches and so forth. Here we are actually trying to figure out what are the simulation patterns that you got to run, and how you can get to the best possible in terms of layout and schematic for your cell in a least amount of simulations done to get to the best optimized final cell. And that's the Solido Cell Optimizer. And PBTMC verifier is another one on the transistor space, where you have multiple PBTs. We actually come up with, across multiple PBTs, we come up with the new way of finding out how to identify a worst case PBT, and then all the way go in and find out within the worst case PBT, what's the key, or what's your actually a target confidence level in terms of sigma. So those are the key things that we use in terms of ML-based AI. So the next one is actually, how can we come up with the PPA trade-off, right? That's one of the big challenges that we see. in terms of the new tapeouts that's happening. So in this case, you got to do a deeper insights, right? And PPA trade-off is essentially about able to understand your big data problem across the entire flow from top to bottom and bottom to up. We introduced a new product, Catapult. This is a tool that we have. So Catapult AI neural network. What we did is we used a high-level synthesis engine. We worked with an open source consortium having an open source package that actually develops, it's called HLS4MR, that actually develops your neural network models. And we use Catapult to generate C++ code all the way to RT. Now, the key thing, what's the key thing is, this is essentially addressing two things. One is in terms of efficiency, how we can generate from your hardware accelerators, AI accelerators, using this flow. But the second thing that really helps is, most of the people who are writing neural networks, they don't know RTL, they don't even know C++. They use PyTorch, right? They use TensorFlow. So there has always been a gap between how that gets translated in an optimal way to a silicon, right? Most of the hyperscalers use this product right now. So we have a flow to actually make that happen, right? So there's actually AI and ML and reinforcement learning built in terms of how we make that happen. So this is another huge productivity gain that we have. And of course, we talked about place and route before in the previous session. Aprisa is our platform on place and route. And of course, right, with every scenarios, you have like all the way from flow plan, placement, routing, post route, everything, your complexity or number of variable increases or explodes. So essentially you have a combination of almost close to, right? And if I have to, I don't think you're able to see the screen here, but for every step, you're actually exponentially increasing the number of permutations in terms of decision-making capabilities. But we do have same case of design space optimization to get to the right point where it gives you the best PPA target, it helps you meet your PPA target. So that's another one that we do for PPA trade-offs. This goes down all the way to the transistor and the bit level or cell level design. In this case, we are using AI, and we are doing a PPA analyzer for essentially in a spice abstraction for multiple parameter design, comparing one output to another output, right? In this case, you are saying that, okay, for this output and this output, what is the best combination of parameters that you need to have in your design to meet your target, right? This is what we call a PPA analyzer. And it also helps us identify the worst violators as well in terms of your parameters. So there are a lot of different ways where you're using AI techniques to get to the same problem, get to the solution faster. So everything is essentially focused on productivity. Now, everyone talked about the talent shortage. This is another one that we have. This is essentially to see how we can get that done. It all has Gen AI capabilities, Copilot capabilities. But the most important thing we do is every product within Siemens EDA, I think that will be pretty much the standard going forward, will be an NLP interface going forward, where you don't need to learn a syntax. You don't need to, if you're running a spice simulation, you don't need to know how to write a measure statement. You can just say, do this, measure this. Sometimes you can even ask your Siri or something like that, voiceover, just a matter of time before it happens. But even the most complex analog kind of problems can be easily solved by engineers or just beginner engineers with less experience. So we're really focusing on that. So we're using generative AI to do a lot of things in terms of runtime analyzer to figure out where the bottlenecks are in your design or in your flow, in terms of assisting to write certain rule texts, write certain assertions using generative AI. So that's more important. And finally, an NLP assistant that can be not just your Docker assist, but integrated within the software products so that it has context to the design and what the designer is doing at that point in time in the flow, right? That's where we are looking at right now. So these are all almost there, or in some of the products are almost coming up in the next few months. And the last is, in terms of extending development cycles. So, Calibre has been signed off for a long time in terms of DRC and LBS. So we are actually coming up with it's one thing to point out there are errors, but another thing to point out how to solve the errors in a much more efficient way. So there's a lot of insights built in right now using AI to actually make that happen so that you get to the sign-off stage as fast as possible. Tessent is another product. So we launched SSN, it's a streaming scan network, 3 years back, and it's been a huge success. Essentially, it uses unsupervised learning. It helps you optimize your scan insertion and scan testing in terms of I/O efficiency. It reduces in terms of your load time, time here in your load tester, significantly, right? That's the real value that the customer sees in terms of cost reduction when we are actually doing design. So that's another product that we have. And another one is we have is in terms of yield management and silicon lifecycle management. We are actually using predictive AI and unsupervised learning to actually point out your worst yield contributors in your flow, in your design, and actually get to solve that problem at a much more earlier stage. So that's what we call test and diagnosis. So that's actually using AI as well. So ultimately, it's helping you solve your problem faster, correctly, and get to the tapeout soon. And finally, we have another one called Solido Analytics. This is another one. So have anyone seen a .lib Liberty file? It's like terabytes long, right, nowadays. But how do you find inconsistencies and issues in the .lib? So we use AI on ML and AI and outlier analysis to actually easily find out what the issues are in a huge file, essentially solving a big data problem. So I think in summary, what I want to say is, we are doing AI for a long time. We are getting into generative AI. We're going to see more and more products coming up. But the most important thing I want to let everyone know is it's actually production grade, in the sense it should be mathematically correct as much as possible for the given use case. And that's what we strive for. And we offer that. And we offer AI workflow across the entire spectrum, all the way from design closure. It helps you in terms of fewer respins. How do you do resource planning, improving your quality of your design and logistics in terms of reporting and everything else. So this is just a eye chart, but these are all the different case studies we have where customers are using and getting the benefits of AI. But this is an interesting thing. I saw another presentation with a different format, but what it tells you is how we are using AI to do it, right? For example, Veloci and emulation side, we use reinforcement learning to figure out how to reduce compile time and to recompile. Because the compile is a huge amount of time that it takes in terms of emulation cycle. So we do that. We have with Tessent I talked about, we're using AI to reduce your test time improvement all the way from 5x. And we have analytics using, in terms of Solido Analytics to debug all your timing files, right, with 50% reduction. And with Caliber products, we have Recon User, right? We use AI to actually help you debug your designs much more faster, all the way up to 15x faster. So there are multiple examples over here, but the key thing is, AI is here. We've been doing AI. AI is there, and AI is definitely going to be helping you, reduce your productivity gap even faster. And it's just a matter of time before we also get into the latest stack that we're talking about, but it's coming. So this is just so I think the takeaway from this slide is all the products within Siemens EDA have some form of AI, and it's only investments only increasing to actually bring in more productivity gains for the users. So that's all I have. Thank you.